Hi, my name is Patrick. I'm here with my colleagues Shannon and Rouen. We're students at Dalhousie University in the Department of Biology. This is our research project on Point Pleasant Park's recovery and succession after the 2003 Hurricane Juan disturbance. So a bit of background on our research project. Hurricane Juan hit the Nova Scotian shores in 2003. More than 80,000 trees were toppled in Point Pleasant Park alone. Here's some terminology we might use today. So secondary succession is the recolonization of a habitat after a major disturbance. Species richness is the number of species in an ecological community. Species diversity is the measure of the number and relative abundance of the different species in an ecological community. And climax community is an ecological community that has reached a state of equilibrium and stability. So in 2004, the Department of Biology at Dalhousie University took advantage of the major disturbance that was Hurricane Juan to answer some questions about succession and recovery that were deemed important at the time. The first question was, how has the overall forest community changed over time, and what will happen to the overall community as the forest moves towards its climax community? Our hypothesis was that the species diversity in the forest should see a steady increase in early years and then level off once it gets close to the forest climax community. Our second question was, how has the density of the dominant species in 2004 as well as the dominant species in 2023 changed over time, and what will happen to the dominant species and the community metrics as the forest moves towards its climax community? Our hypothesis was that the dominant species in 2004 should see an increase in the very first few years and continue to increase at a consistent slower rate afterwards. The dominant species in 2023 should see an exponential increase in abundance and then level out once the forest has reached its climax community. Our last question was, how has the species richness changed over time, and what will happen to the species richness as the forest moves towards its climax community? Our hypothesis behind this question was that the species richness should see a steady increase followed by a plateau in the forest's intermediate stage before slowly decreasing once the forest gets closer to reaching its climax community. So our methods for this project, starting in 2004, students and experts from Dalhousie's Department of Biology went to 5 different 20 square meter sites at Point Pleasant Park in Halifax, Nova Scotia, as you can see here illustrated. Data such as the tree species and abundance of those species were taken in from those 5 different sites. Species were identified visually by experts who defined a tree as a wood growth that was 2.5 centimeters in diameter at breast height. Data collection happened every year at the same 5 sites since 2004, other than 2005, 2007, 2016, and 2020 due to other unforeseen major disturbances.
Over time, the forest community in Point Pleasant Park has made evident recovery. It has become more diverse and more mature. This can be seen here in Figure 1. As the years continue, the Shannon diversity value rises. A higher value means a greater diversity. As the p-value resulted in 2.0 times 10 to the power of -7, it is an extremely small value, resulting in evidence to support the alternative hypothesis. There is significant change in diversity of the forest over the years at Point Pleasant Park, and reject the null hypothesis, which is there is no change in diversity in the forest over the years at Point Pleasant Park. As the S statistic for this data is 33.6, it is statistically significant and further supports rejecting the null hypothesis. Overall, this data suggests a big change and increasing diversity, and in the future it may continue this way for a period of time until it becomes a mature, old-growth forest. Once it reaches the climax stage of succession, diversity is likely to remain stable, as the forest will have been in a fixed state with species that are long-lived and constant, and because of this and the ecological relationships of all types of plants and trees in the community, there is less opportunity for new species to develop.
So as you can see here, we have the graphs that represent red spruce and red maple population abundance throughout the years. This data answers our question of how has the dominant species in 2004 as well as the dominant species in 2023 changed over time, and what will happen to the dominant species and the climate and the community metrics as the forest moves towards its climax community. So in the past 20 odd years, both the dominant species in 2004 and the dominant species in 2023 have made an obvious recovery. The former, being the red spruce, has increased its numbers at a steady rate. This is illustrated in figure 2.1. As the years progress, so does the red spruce's abundance. The p-value for the red spruce population was quite small at 0.004, which supports the alternative hypothesis that there is an increase in population abundance of red spruce over the years at Point Pleasant Park, and rejects the null hypothesis that there was no change in red spruce population over the years at Point Pleasant Park. The F statistic for this data is 8.72, which is statistically significant and supports the rejection of the null hypothesis. The red maple has had an even more successful recovery, leading to it being the dominant species in 2023. This can be seen in figure 2.2. The red maple's population abundance increases significantly after the years pass. The p-value for the red maple's population abundance is extremely small at 7.9 times 10 to the negative 5, which supports the alternative hypothesis that there was an increase in population abundance of red maples over the past years at Point Pleasant Park, and rejects the null hypothesis that there's no change in the red maple population abundance over the years. The F statistic for this data was 17.4, which is statistically significant and further supports the rejection of our null hypothesis. The data suggests a big change in dominant species over the past 20 years or so. According to the statistics, we will likely see the continued dominance of the red maple when the forest reaches its climax community. If it continues to dominate the area, we will likely see a red maple dominated Acadian forest type that will eventually become an old growth forest, as that point of dominance of the red maple should remain fairly constant at an equilibrium with other species.
Species richness was explored to determine the stage of succession of Point Pleasant Park following Hurricane Juan in 2003. Following the secondary disturbance of the park, the overall species richness has steadily increased despite variations across multiple sites, as shown in Figure 2. After applying a linear regression model to the data collected from 2003 to 2022, with the previously mentioned 4 exceptions, species richness was found to be the best fitted metric with an R-squared value of 0.66, representing a relatively small difference between observed data and the linear regression model applied. After analyzing the data collected up to 2022, there was a strong positive relationship between species richness and time, with a p-value of 2.2 times 10 to the power of negative 16, an F statistic of 142.2, and an R-squared value previously mentioned of 0.66, demonstrating how Point Pleasant Park is increasing in number of species as it recovers from Hurricane Juan. This leads us to reject the null hypothesis that there's no change in species richness at Point Pleasant Park over time, and accept the alternate hypothesis that species richness should see a steady increase as Point Pleasant Park approaches a climax community. Following the chronosequence model used by Ed in 2000, it is likely that species richness will continue to increase and plateau during its late intermediate stage before slowly decreasing. As Point Pleasant reaches its climax community, red spruce abundance as well as red maple abundance should rise, increasing canopy cover and limiting light penetration to the soil. As a result, species that can't compete for height and require larger quantities of light will struggle to gain resources against the likes of red spruce and the red maple. As Point Pleasant Park approaches its climax community and canopy cover increases, the number of species should see a small decrease before finding a state of equilibrium.
Based on the data, the current succession stage would be intermediate or mid-stage. Grasses and shrubs are evident, as well as many fast-growing coniferous and younger, slow-growing deciduous trees. However, it is obvious that these trees are not fully mature when taking their measurements into consideration. The succession and recovery of this Acadian forest in Point Pleasant Park may be affected by separation from other more developed forests, also known as fragmentation. An urban forest is often heavily interacted with humans and pets, leaving less space for wildlife populations to flourish. With less access to wildlife for things like fertilization and seed distribution, reforestation is likely to take a lot longer, and the establishment of animal and plant interactions in a forest is a very important aspect of forming a healthy ecosystem. As Point Pleasant Park is also located in a hotspot of movement with ships and trains, it is vulnerable to the introduction of invasive species. From even before Hurricane Juan, Point Pleasant Park has been suffering from the brown spruce longhorn beetle, likely brought over from ships. This is an issue as it will attack the young trees, inhibiting healthy growth. In addition, Himalayan balsam, which is a plant people like to plant in their gardens, is another invasive species, and it poses a threat to the ferns and shrubs of the Acadian forest. To Mi'kmaq people, Point Pleasant Park is a part of the land that has very significant importance. It was a location where the Great Spirit Fire, whose sparks gave birth to the 7 original families, would sit. In understanding the sacred space of creation and cultural significance, the push for the forest recovery and preservation is not only coming from a biodiversity and environmental aspect, but from a cultural aspect as well.
In the event of another hurricane the size of Juan in Point Pleasant Park, the abundance of the red maple and the red spruce should see a very significant drop as the hurricane tears through the remaining older population of the red spruce and red maple. However, it is likely that more of the saplings persist this event, as found in the studies of Henry Solon Graves. Other community metrics such as species richness and Shannon diversity should also be reduced, similar to those of Hurricane Juan. Although Category 3 hurricane exposure could result in increased basal areas in younger trees, as shown in the studies of Flynn in 2009, it is almost certain that a hurricane the size of Juan would topple most tall trees in the area. And finally, as observed in the studies by Zhu Linhao in 2020 and Schnitzer in 2005, native species regeneration could be suppressed by invasive species such as the Himalayan balsam or the multiflora rose, both species that have appeared in Point Pleasant that are invasive and suppress growth of the native species in the park.
So another important question to ask is, does climate change have an impact on the regrowth and recovery of species in Point Pleasant Park? And are there any particular effects of climate change that would impact succession? So first of all, the change in annual temperature would have an effect on the various trees' fundamental niches. Different trees will react differently to different temperatures. So the species that thrived in the original temperature might find it harder to survive in the new one, and trees that were once struggling to survive might be favored and become more dominant. Second of all, Point Pleasant Park is situated on the coastline of the Atlantic Ocean, where climate change is having serious impacts on global sea levels. With rising sea levels, the soil around the park will start to change in ways we don't fully understand yet. The change in soil composition could have favorable and unfavorable consequences to various tree species in the area and drastically change succession. These changes will ultimately have an effect on the different species trees realized niche.
Two-eyed seeing is a method of co-learning that instills important spiritual and emotional relationships into scientific database research. It intertwines both indigenous and Western knowledge and ways of seeing into one as a cooperative effort to understand the world around us better. Using Point Pleasant Park as an example, this allows us to take into account that the space holds deep and spiritual relationships to many over hundreds of years, providing historical records for this indigenous knowledge. This may allow for us to obtain a greater understanding of how we can purposefully rehabilitate the ecosystem to its original state, and these connections bring a sense of unity to truly create an impact that feels more personal, almost as though we are helping out an old friend. As we work on the reforestation of this current space in Point Pleasant Park, future generations may not need to continue to tend to the forest in the same way. However, they will have the skills, research, and social support as well as connection passed on to them to put to use for future ecosystems that may need the help in the future. As stated by Elder Albert Marshall, science alone is not what will preserve our natural world, but instead a change of point of view, and that combined with research and action is how success will be obtained. As the world around us changes, the need to protect and honor the land as well as study and learn from it will always remain, and it is a privilege to do so with an open, educated, and two-eyed seeing mind.
We would like to start by acknowledging Dalhousie University and the students of previous Biology 2060 classes who collected the data presented today. We would also like to acknowledge that the research took place on the traditional, ancestral, and unceded territory of the Mi'kmaq people, who have given us the opportunity to live and learn on their traditional lands. We would also like to give thanks to Dr. Alison Schmidt, who analyzed the data necessary to conduct our research, as well as Abigail Target, who helped us guide us with our studies.